Why do kernel sizes matter in CNN convolutional layers? Imagine trying to spot tiny details or broad patterns in a picture. The size of the window you use to look at parts of the image makes a big difference. That window is called the kernel in convolutional neural networks. Kernel size is the height and width of that window. It controls what part of the image the network examines at one time. Smaller kernels, like 3 by 3, focus on small details. Larger kernels, such as 5 by 5 or 7 by 7, look at bigger areas. This choice affects what features the network learns. If you want to detect textures or small objects, smaller kernels are better. They help the network pick up fine details. Larger kernels are useful for understanding bigger shapes or the overall layout of an image. They can see more of the scene at once. Using smaller kernels also makes the network more efficient. Stacking many 3 by 3 layers can give the same effect as one larger kernel but with fewer parameters. This means less memory use and faster training. When you use larger kernels at the start of the network, you can grab more global information from the raw input. But deeper in the network, smaller kernels are more common because they help learn complex features step by step. Kernel size also influences the size of the output feature map. Larger kernels shrink the spatial dimensions faster unless you add padding. Padding adds extra pixels around the image edges so you don't lose important information at the borders. In applications like image generation or natural language processing, choosing the right kernel size helps the model pick out meaningful features. For example, in image creation tools like DALL-E or Midjourney, small kernels focus on textures and fine details, while larger kernels help understand shapes and context. Bigger kernels also mean more weights in the model, which increases memory needs and training time. This raises concerns about computational resources and energy use. Picking the right kernel size balances the ability to learn useful features with the resources available. In the end, kernel size in convolutional layers shapes what the network can see and learn. It determines whether the model focuses on tiny details or big picture patterns. Choosing the correct size is key to building efficient and effective artificial intelligence systems that can analyze images, text, or other data accurately.